Alright, hello, how you doing? My name is Mr. Beker, and I am going to do over lesson number 12. Alright, so we are going to solve quadratic equations, okay? I have the handout right here just in case you think I don't. And it says that you can solve any quadratic equation of any type. You can relate quadratic equations to the real world. Well, let's go. First of all, a quadratic equation is of the type ax squared plus bx plus c equals 0. Okay, that's the first thing you write. So what is this? Okay, it's the standard form, okay? Standard form of quadratic equations. So that's the standard form. Now, what do these A, B, and C represent? They represent A, B, and C are coefficients. And what does that mean? Nothing more than regular numbers. A is a regular number, B is a regular number, and C is a regular number. When I ask you for the coefficient of A, I don't want you to say, let's say I have, let's give an example. Let's say I have x squared minus x, okay, plus 6. If I ask you for the coefficient of x squared, you have to say that the coefficient is 1. If I ask you for the coefficient of the linear term, okay, this is the quadratic term, this is the linear term. If I ask you for the coefficient, you say it's -1. If I ask you for the coefficient of c, you say that is 6. Okay? The loose number is always c, the linear term, and this is the quadratic term. Quadratic because it's to the second power. Okay? And if you know how to say, for example, square in Spanish, you know it says cuadrado. So therefore, that's why they call it quadratic, because it's not English nor Spanish, it's actually from the Latin. So, what else do you need to know? Yes, you need to know the following. Every quadratic equation is equal to 0. Every quadratic equation is equal to 0. If it's not equal to 0, you have to make it equal to 0 by adding or subtracting here and putting it on the other side with the opposite sign. Okay? Every quadratic equation is equal to 0. No buts or ifs. It is equal to 0 and that's it. It's over. Now, what is another way of writing 0? Well, I'm going to show you. You could have the quadratic equation in standard form, and now instead of an equation, you could turn it into a function by switching the 0 to a y. So now we have y equals ax squared plus bx plus c. As simple as that. Alright then. So how do I solve a quadratic equation? There are so many ways of solving quadratic equations, but we're gonna go through some that are very familiar. For example, in the last lesson we learned how to factor. Guess what? Factoring is very important because it's a tool that you're gonna be using right here. All you gotta do is factor the quadratic terms, okay, the polynomial, factor it, and then set each factor to 0. So let's see how we do over here. We're going to we're going to solve, okay, x squared minus x equal to 6. Alright, so this is a quadratic equation because the leading exponent is 2, or the highest degree. Degree is another term for exponent. The highest degree is 2. Okay then, so what am I supposed to do? What is the first thing I said I had to do? Every quadratic equation is supposed to be equal to 0. So I'm gonna make that equal to 0. So take this 6, you got it? Okay, now give it back to me. You know that when you give it back to me, how you give it back to me? Right, -6. And now since I removed it here, all I have here is a 0. Now the next step, now that the quadratic equation is equal to 0, I'm going to factor. So how do I factor? Well, I see if I have a GCF, remember? And I don't. GCF is 1, so I don't have to do anything. All I have to do is open the little open the little and equal it to 0. So let's ask ourselves, by now we should be pros at factoring. By now we should have mastered factoring. So what are the factors of x squared? X and x. Okay? What are the factors of 6? 3 and 2. Let's use the smiley face to see if we get the middle coefficient. What is the middle term? Negative 1x. Okay. So here I get 2, here I get 3. How do I get negative 1? Well, let's do negative 3 plus 2. See that? So I have negative 3x plus 2x is negative 1x. So yes, this works. But guess what? When you were factoring, this was more than enough. Now you're solving. So that means that you gotta equal each of the factors to 0. Alright, so I will say x minus 3 is equal to 0. X plus 2 is equal to 0. I set each of the factors equal to 0. So let's solve for here. All I need is to solve for x. So I'm going to take the negative 3 and I'm going to put it on the other side. And that becomes positive 3. By now, you should already know what's going on. Here, x equals negative 2. I take the positive 2, put it on the other side, and that's it. Now, is there an easier way of doing it? I mean, come on, guys. Look, this is supposed to be equal to 0. What number minus 3 is 0? 3, because 3 minus 3 is 0. Here, what number plus 2 is 0? Negative 2, because negative 2 plus 2 is 0. Now, I want you to tell me something. What is the relationship between the solutions to the quadratic equation and the factors of the quadratic equation? I want you to take a look at both of them and tell me what relationship do you see between these factors and these solutions. Correct. You see, they are opposite to each other. So now you understand. So what if I had given you something like, oh, write me a quadratic equation that has roots or solutions, okay, of 3 and negative 2? Well, you would have to revert back to the factor form. In other words, make each of these equal to 0. So what makes this 3 0? Minus 3, right? So then you have x minus 3 here. What makes this 0? Well, you add 2 to both sides, so you get x plus 2. See that? And of course, everything was made equal to 0. And then you have to use the distributive property to multiply this, and you're gonna come up with your original problem right here. Got it? Alright then. Now of course, I had already given you the steps right here on the handout, just in case, but just go over it. See that? Set each factor equal to 0. I'm telling you what to do. I'm telling you what each of these is called when you solve it. They are called roots, okay, or solutions, or x-intercepts. All right then. So let us solve this little problem for y. So the first thing I'm going to do is the following. Here, it's a special case. Why? Well, because at plain sight, I can see that y squared equals 16. I can undo this square. I can actually take the square root of this one and take the square root of this one, okay? And I will easily know that the square root of y squared is y, okay? And the square root of 16 is positive 4 or negative 4. How is that possible? Well, positive 4 squared is 16. And guess what? Negative 4 squared is also 16. So this will be my solution, but you have to be careful. The only way to do this is when you have something square equaling to a number that has a square root. Like, I could have x squared equals 64. I know that the square root of 64 is 8. I could have I could have y squared equaling to 4. And I know that the square root of 4 is positive or minus 2. So that's how it works. Anyway, let's do it the same way we were doing the other problem. So I need to set this equal to 0. So take the 16, okay? And now you know that the 16 went onto the other side. See that? And now let's proceed to factor. I notice that I don't have a middle term. So therefore the middle term is 0. I tried to find the GCF, but the GCF is just 1, so I don't have to do anything to it. Then I open the little parenthesis. Okay? Factors of y squared, y and y. Factors of 16, 4 and 4. Remember, it's a quadratic equation, so it should be set to equal something, like 0. Alright, since the middle term is 0, you know that between this and this you need 0. So make one positive and make one negative. Okay, now I'm going to set each of the factors equal to 0. So what makes y plus 4 0? What number for y plus 4 give me 0? Negative 4. What number minus 4 is 0? Positive 4, and you got it. It's the same thing here, here, it doesn't matter. Okay, so let's read this one. Write a quadratic equation in the form of ax squared plus bx plus c equal to 0, whose roots are 2 and 5. Well, remember what we said about the relationship between the roots or solutions or x-intercepts and the factors? Sure. So then, first ask yourself, what is the relationship between the roots and the factors? Well, they're opposite to each other. So I already know what the factors are going to be. The factors are going to be x minus 2 and x minus 5. It has to be minus because this 5 is positive. And then remember, equal to 0. Okay then, now multiply the binomials obtained. Alright, so you know that this is going to give you x squared. And then when you do the smiley face, that's going to give you the middle term. So you got negative 5x and negative 2x. You have negative 7x. Negative times negative is positive, so then you know this is plus 10. As simple as that. Okay. Solve for x. Here you have a problem of a different kind. This is called a proportion. And there are many ways of solving this proportion. You could follow the golden rules to solve linear equations, okay? Which is like, oh, we have a denominator, so we're gonna multiply by the common denominator. And that will get rid of the fractions. We could do that, or simply, if you were taught in middle school, we could just cross multiply. And let us do that, let us cross multiply. So x times x is x squared, right? Now 9 times 144 is, I have no idea. So we're gonna have to do it. Okay, it's 1296 is 1296. Now what is the sign? The sign must be equal. Okay? And now what do I do? Nothing. You could set this, look at this. We could figure out if 1296 has a perfect square root, okay, and we can undo the squaring. So let us figure out. Square root of 1296 is 36. So therefore, I take the square root of both of these little rascals and I get x equaling to plus or minus 36. Now, is there another way I could have done this? Yes, the same way, the classic way, the same way we've been solving the other equations. Take the x squared equaling to 1296 and now set that equal to 0. So in other words, take the 1296, give it back to me, and went onto the other side negative, and that equals 0. Now I find the GCF. There's no GCF. It's actually 1, so I don't need that. So I open the little and now factors of x squared, x and x. Factors of 1296, 36 and 36. Remember, there is no middle term here. There is no linear term here. So I guess I lost it. So one has to be positive, the other one negative. And that's it. Okay. Let's do something more rigorous. Okay? Something that requires more thought. Like this problem right here. So, you could either find the LCD or you could just cross multiply. In this case, I'm just gonna cross multiply, but I'm gonna cross multiply step by step so you don't get lost. So cross multiply, so 3 times this, or x plus 2 times this, I'm gonna write it down. I'm gonna say 3 times x plus 2, see that? Equals, and then 2x plus 1 times x minus 2, these two. I could have done it right away, but I want you to see what I do. So let us see what we get. 3 times x is 3x. 3 times 2 is 6. 2x times x is 2x squared. 2x times negative 2 is negative 4x. 1 times x, you see I'm done with this one. I've multiplied by everything inside the parentheses. And now I am going to multiply the number 1. So 1 times x is 1x positive. 1 times negative 2 is negative 2. Okay, now what? Now I gotta combine the like terms. So let's see, there is no like terms here, so I just rewrite 3x plus 6. So that's good. I hate the way I write number 6, so I'm gonna try to make it beautiful. Nice, beautiful, oh gosh. 2x squared doesn't go with anything, so I just rewrite it. Negative 4x goes with x, so that's negative 3x. And then negative 2. Okay, so that's what we have. Here you're gonna learn something else, okay, a secret. This is a quadratic equation, and I need to solve it. Here it's not like I can take the square root of everything. I cannot take the square root of everything, so I am going to just have to set it up equal to 0. Okay, so how do I set it up? How do I set it equal to 0? Easy. Make one of the sides 0. And for the purposes being, I need you to understand something. We always need the term that is squared to be positive whenever possible. If not, it's okay. So that's exactly what's going to happen. I am not going to move anything from here, because if I move this 2x squared to the other side, it's going to become negative. So I am going to move the 3x and the 6. Boom, I did. Wait, I didn't. I gave them to you. I need you to give them back to me. Whoop, thank you. So the 3x, you gave it to me with the opposite magic. And the 6, you came to me with the opposite magic. So that's what I have. Ah, you like that, right? Sure. As long as you learn it. Oh my God. So we add the like terms again. So we have 2x squared. Negative 3x goes with negative 3x, so that is negative 6x. Negative 2 minus 6 is negative 8. And look, is equal to 0, so I'm holding the equation true. Now, let us factor. I'm not going to open the parentheses yet, because I need to first find out if there's a GCF, which in effect we have one. Look, 2 can be divided by 2. 6 can be divided by 2. 8 can be divided by 2. So I need to take that 2 out. Now let's see if they all have x in common. X, x, oops, no x. So that's it. 2 is the only GCF, greatest common factor. So 2 times what is 2x squared? X squared. Minus 2 times what is 6x? 3x. Okay? Or 6x divided by 2 is 3x. Whichever way you want to say it. 8 divided by 2 is 4. Or 2 times what is negative 8. Okay, now I think I can try to factor this. I'm not promising you that everything is factorable, but let's see. So now that I got the GCF, and I actually factor out the other terms, then I am going to open the little okay? So factors of x squared, x and x. Factors of 4, I know how to write 2 and 2, but 2 and 2 here will yield 2x and 2x. That's never going to be 3x. So I'm going to use 4 and 1. So this is going to be 1x and this is going to be 4x. I need negative 3x, so it's going to be negative 4 plus 1. Cool. Is that the end? Hell no. That's just the factor form. I need to set each of the factors to 0. Of course, each of the factors that includes a variable. So, what number makes this 0? What number makes this 0? That, right? Okay, now watch this and don't be mad at me. You see this right here? We can actually graph it. So we go and I'm gonna make this smaller, a little smaller. Okay, you can see now. I am going to type exactly what I see. So I'm gonna press y equals. Okay, I'm gonna clear everything that's there. And now I am going to write a fraction. So it's gonna be alpha y equals, boom, fraction, right? My top fraction is gonna be x plus 2. Then the bottom fraction is going to be 2x plus 1. Okay, let me see now. Okay. Nope, I cannot do it like that. So if I cannot do it like that, yeah, I can't until the equation is equal to 0. Sorry. I mean, I can, but I'm not gonna show you how to do it like that. Sorry. Let's say I worked my problem out and now I equaled it to 0. So, and I added the like terms. So let me try to do this one. 2x squared, okay. 2x squared minus 6x minus 8, okay, and then I'm gonna graph. Now guess what? We are setting the equation equal to 0. We said that another way of writing 0 was y. So what we're gonna go is we're gonna go to the table. First we look at where our possible solutions could be. And now look at this. When y is 0, okay, x is negative 1. Bada boom. So I guess let's go on to x equals 4. Look, when x equals 4, y is equal to 0. Remember, the solutions happen when y is equal to 0. Okay? So now, I just showed you how to do it on the calculator. Now the graph, look at the graph. The graph is actually a parabola. It's a U. Okay, it's a parabola. You already had one of these problems in one of the quizzes, how to graph parabolas. But don't worry, we're gonna go over it later on. Okay, so solve for c. You got c squared minus 12 equals c. All right, 3 terms. That means that I cannot just take the square root of a number, so I have to equal it to 0. So take this. Now usually you want to write your numbers by degree. So to the second power, and then to the first power, and then to the 0 power. In other words, nothing. And then that equals, well, this was moved from there. By subtracting c, we get 0. I know there is no GCF because I don't have time to waste on here. Okay. Okay, 3 times 4 is 12, yes. And 4c and 3c. I need a negative 1c, so I know what to do. Right here, boom. Okay? I was drinking Gatorade. Look. Gatorade. Oh, the G. The G. Alright. So now, is this my final solution? Hell no. This is just your factor form. Remember, you gotta equal each of the factors to 0. And I already know that the roots are going to be the opposite of the factors. Let me see. You have to be kidding me. All this? Okay. So, football. So it says, in football, the height of the football reached during a pass can be modeled by the equation h equals negative 16t squared plus 28t plus 6, where the height h is in feet and the time t is in seconds. How long does it take for this ball to reach a height of 12 feet? Well, we have the equation here, okay, where the height is in feet and t is in time. So, let's see. How long does it take for the ball to reach a height of 12 feet? We don't know. But what we can do is we can substitute. So what am I going to do? Substitute the 12 into the equation for h. So you see what the equation was? Now you substitute. So 12 equals negative 16t squared plus 28t plus 6. Now guess what? Get all terms on the same side. Move terms to the left side to avoid working with a negative leading coefficient. Alright, what does that mean? That instead of moving this 12 over here, okay, instead of moving this 12 over here to the other side to make this 0, if I had done that, I would have been working with a negative 16t squared, and I don't want to do that. I want to be working with a positive 16t squared. Okay, so instead of moving this over here, I move everything to the other side. So this becomes positive 16t squared, this becomes negative 28t, and this becomes negative 6. See that? And that's what I have here. Something is not right. So let me see now. Okay. Get a term, move the terms to the side. If I do, this becomes... Oh, my bad. Okay, the reason why I thought this was going to be negative 6. Yes, but the thing is that when you do negative 6 over here, then you're going to have to do 12 minus 6, which is positive 6. Whew, I thought I was losing it. Alright, and now I proceed. Is there a GCF? Hell yeah, there is a GCF. So I'm going to use the GCF right now, the greatest common factor. I know I factor it right here, the way you see it, and it's still going to give you the same answer, but let's find the GCF. So, can all of them be divided by 2? Yes. What about 3? No. So let's divide each and every one by 2. So in other words, 2 is my GCF, and when I take it out, I end up with 8t squared minus 14t plus 3. Okay, this is the same thing as this one. And now all I gotta do is factor this part right here. Remember, equal to 0, equal to 0. So, factors of 8t squared, 2t and 4t. I'm just taking a wild guess. Now I need factors of 3 and 1. If I put the 3 here, I'm gonna have a 12. Okay, and I think that's where I'm gonna put it. See, if I put it here, I'm gonna have a 12t, and then remember it's 3 and 1, and the 1 right here gives me 2t. So 12 and 2, that's 14. So all I gotta do is make them both negative. Okay, so that's what I get. Now, when I set each of these equal to 0, we're gonna have a little surprise. So 2t minus 3 equals 0. Alright, so I'm supposed to solve for t. Okay, so get rid of this negative 3, put it here. Okay, and then divide by 2, so you get t equals 3 over 2. Okay, this one, if you do it on your own, you get t equals to 1/4, because I'm gonna move this to the other side so it becomes positive, and then I'm gonna divide by 4. Okay then, so let us see if we get the same result when we did not take the GCF out. Alright, here it's already known that I'm gonna get 1/4, because I'm gonna put this t on this one on the other side and divide by 4. Now the other one is 4t minus 6, okay, equals 0. I'm gonna move the 6 over, so I'm gonna get 4t equals 6. I'm gonna divide by 4, and I'm gonna get t equals 6/4. Guess what? If you simplify 6/4, you're gonna get 3/2. So yes, you end up with the same answer. It's just that sometimes they want you to factor completely, and you have to do it like that. Alright. After step 1 on the above exercise, choose a different approach in factoring. I just did. Wow, I should have never done that for you. Oh, this was supposed to be okay, fine. I did it. Okay, now I am going to show you something that we might not see here in geometry, but it's good to know. It's called solving an equation, solving a quadratic equation by completing the square. So, what you are going to do is we are going to go over the steps, and let's see if it works. So, this is the original problem right here. Okay? So it says, I'm gonna zoom in the original problem, and I am going to read with you the steps. So it says, move the loose number to the other side. I know that all quadratic equations are equal to 0, but this is just another strategy called completing the square, so just bear with me. So change this 5 to the other side so you know that it is positive. Then divide everything by the leading coefficient. Make sense? Okay, so I'm gonna divide everything by 4. Cool. So 4 divided by 4 is 1. A half. Sorry, -2 divided by 4 is -1/2. 5 divided by 4 is just 5/4. Now, take half of the coefficient of the linear term, of the x term. Okay, half of 1/2 is 1/4. If you don't believe me, I'll show it to you. I have 1/2 here, and I am going to divide by 2. Divide by half. Divide by 2, I'm sorry. So when you take half of 1/2, this is what's gonna happen. When you divide here, then the secret is that keep the first term, change the division to multiplication, and use the reciprocal of the term. So you flip it, you see that? So now guess what you have? You have 1/4. Got it? Okay then. So I get 1/4. Now what to do with this number? It says square it. Okay, all I'm doing is following steps. Okay, so if I square this, I get 1/16 positive. Then it says add it to both sides. So I do. Now when you add it, once you reach this step, you have reached the point where this term right here turns into a perfect square trinomial. What the hell is that? We did that before. It's nothing more than a binomial that is squared. Okay? So x right here, remember when I said take this, put it together with this, multiplication, double it, and then square this one? Same thing but backwards. So x squared is x. What is the number that we squared? It was 1/4. See that? So That's exactly what you're gonna do. X minus 1/4 squared. And remember that you were dividing by, you were adding 1/16 on both sides. So 5/4 plus 1/16, if you do it on the calculator, you're gonna get 21/16. Now, after this step, remember that you are solving for x. You want the value of x. So after all these things, you're gonna take the square root of the x binomial. So let's see now. When you square a number and you take the square root, you are doing inverse operations. So that means that they cancel out each other. So you end up with x minus 1/4. And here, well, I don't know what the square root of 21 is, but I know what the square root of 16 is. It's 4. So you end up with the square root of plus or minus 21/4. Now, is this the end? No. I still need to solve for x. This is bothering the x, so I'm gonna have to add 1/4 to both sides. And this is what you end up with. Now, if you didn't understand what I just did right now, don't worry. All you have to do is read the instructions. You read the instructions, you follow the instructions, and you will be okay. You don't follow the instructions, you don't study, you won't be okay. Alright. So, let us do one of those problems by completing the square and see if you understood. So, I have this problem right here. I think we did it before by factoring, but now we're gonna do it by completing the square. So, it says, move the loose number to the other side. Those are the rules. So I'm gonna write x squared plus 6x equal to 7. Then it says, take the linear term, so 6, take half of it, that's 3, okay? 3, and then square it. So that becomes 9. Alright, now after that it says add it to both sides. Okay, so I'm gonna have x squared plus what? I don't remember. Let's see what it was. Oh no, I did good. Yeah. All right. So x squared plus 6x. Okay, nothing changed over here. And then add the number that you took half and squared. So that's what we have. Now you have created a perfect square trinomial. I'm gonna show you how to do it. If you were to factor this out, you would have gotten x plus 3 times x plus 3. But since we are not going over that, we're not expanding, we're just writing the perfect square trinomial square, that's not a problem. So we reduce the perfect square trinomial. So in its factor form, it's going to be x plus 3 squared. Remember, the x term, it's always going to be here. And you ask yourself, what was the number that I had squared? It's 3. So you put it over here. And that, my friends, is going to give you x squared. Then you put this together, 3x, double it, 6x, square this, 9. So it is the same thing. I hope you understand. 9 plus 7 is 16. Alright, and now we square root. I got a square root in order to solve for x because I need to get rid of the square, so I'm going to square root. Okay? When I square root here, I get x plus 3. When I square root over here, I get plus or minus 4. Guess what? I still gotta solve for x, so I'm gonna subtract 3, right? So I get x equal to negative 3 plus or minus 4. Okay, so what is negative 3 plus 4? Is 1. What is negative 3 minus 4? Negative 7. And that is your solution, or those are your solutions, also called roots, also called x-intercepts. Okay, Good. Now you are going to do this problem on your own. Okay? So remember to follow the instructions. Okie dokie. So this is your independent practice. It says, find 3 consecutive positive even integers such that the product of the second one and third integer is 20 more than 10 times the first integer. Oh, ha ha ha, very funny. Alright, consecutive integers are 1, 2, 3, 4, 5. Now, consecutive positive even integers are 2, 4, 6, 8. But since I don't know what the first integer is, I'm gonna call it x. Do I know what the second one is? No, so I'm gonna call it x plus 2 because I know that even integers go by 2s. And the third one, I'm gonna call it x plus 4. Does it make sense? Okay, we okay with this? Alright then, now let's talk about what to do with this. It says, such that the product of the second and third, so the second and the third, so the product of the second and the third okay, the second and the third is 20, that means equal sign, 20 more than 10 times the first. 20 more than what? 10 times the first. 10 times x. Alright, now I can solve. So let us use the distributive property. They want me to find the integers, the 3 integers? Sure. So let's use the distributive property, or let's just use the smiley face method. X times x is x squared. Okay? Then this is 4x and this is 2x, that's 6x. Then this is 8. So far so good, yes. Alright? Now, that equals 10x plus 20. So you have a choice. You could solve it by factoring or by completing the square. It really doesn't matter. I'm gonna do factoring. Oh my god, I'm tired. Okay, so first I need to set this equal to 0. So I'm gonna have x squared plus 6x plus 8 minus 10x, and you could explain to me why is minus 10x, and also explain to me why minus 20 equal to 0. Now let's add the like terms. So I have x squared, 6x goes with negative 10x, so that's minus 4x. 8 goes with negative 20, so that's minus 12. And that is equal to 0. Now, I am going to factor. First, I need to find the GCF. There is no GCF, so then I just open the little Factors of x squared, x and x. Factors of 12, 3 and 4. But 3 and 4 are 3 times 4 is 12, but that's not gonna give me 4. What about 6 and 2? Okay? So when I do the smiley face, I get 2x and I get 6x. How do I get negative 4x? Okay, negative 6x plus 2x is negative 4x. And negative 6 times 2 is negative 12. Am I done? No! I need to know what the answer is. Well, here, if I set this equal to 0, I get x equals 6. If I set this equal to 0, I get x equal negative 2. So let's answer the question. What is the answer? 6 or negative 2? Correct. The answer is 6 because it says 3 consecutive positive even integers. Of course. Okay then. So now, let me do this problem, but before I do this problem, I wanna know something. Oh, I thought it was the same. Okay, it's not. Alright, so to solve this, I need to really, this is a proportion, so I'm gonna cross multiply. So let us cross multiply. This time, okay, I am not going to take my sweet time explaining to you that is the whole binomial times this whole binomial, and then this whole thing times this whole thing, that you really gotta use your distributive property. I'm not gonna do that. I'm just gonna go over it the same way I would go my way, using my style. Okay? So x times 2x is 2x squared. Okay? Again, x times 2 is 2x. I'm done with this, now I'm going with this one. Negative 2 times 2x is negative 4x. Negative 2 times 2 is negative 4, okay? Then the equal sign. Now I'm gonna start here. X times x is x squared. X times 4 is 4x. Negative 1 times x is negative 1x. Negative 1 times 4 is 4. Okay? Now I'm going to add the like terms if I have any. So I have 2x squared. 2x minus 4x is negative 2x minus 4. Equaling. And here, what are the like terms? Well, I have x squared. And then I have 4x minus 1x. That's positive 3x plus 4. Now I need one side to be equal to 0. Otherwise, it's not in standard form. Okay. So which one has the lowest leading coefficient? In other words, which of the x squares has the lowest value? I think this one. So that's the one I'm gonna get rid of. Okay? So I'm gonna take it and I'm gonna put it on the other side. That means that I have made my choice. That means that I want this side to be 0. Okay, no problem. So I write 2x squared minus 2x minus 4. And now let's start making each of these equal to 0. So minus x squared is no longer here. Minus 3x, I'm putting it on the other side. And minus 4. And now everything has been gotten rid of. So this is 0. Now, let's see what's going on. Let's add the like term. So negative 2x squared minus x squared is 1x squared. Okay. Negative 2x and negative 3x make negative 5x. Negative 4 and minus 4, that makes negative 8. Yeah, you thought it made 0, right? Haha. Okay then, I'm ready now. Wow, all that work, but now I have simplified it here, and now I'm ready to factor. I tried to find a GCF and I found none, so I'm good. Factors of x squared, x and x. Okay? Factors of 8, 4 and 2. Wait. Something is not right over here. Let's see. 2x times 2x is that. X times 2 is 2x. Negative 2 times 2 is negative 4x. Negative 2 is negative 4. Aha. X times x squared. X times 4 is 4x. Negative x and negative. Ah, my God, this is negative 4. Ah, my God. You see how a mistake can mess everything up? This is minus 4. This is, so then negative 1 minus 4 is negative 5. Okay? Once again, this is minus 5. So if I have negative, now when I put this onto the other side, it becomes positive. So negative 4 plus 5 is 1. Oh my God, what am I talking about? This was negative 4. Okay, so this, oh my God. So negative, where was this? No, there were no like terms right here. Okay, so far so good. Here was minus 4, okay. Now here I don't have, this is still negative 4, okay, negative 4. Now when I put it on the other side, it becomes plus 4. So this negative 4 cancels out with this plus 4. So there isn't a loose number. And because if there isn't a loose number, then I gotta go back. So I got x squared minus 5x. So I will try to find a GCF, and effectively the GCF here is x. See, they have x in common. So I am going to write it. I'm gonna have to write over here. Okay, I'm gonna have to write over here. So x, take out the x, the common factor, and now x times what is x squared? X times what is negative 5x? Negative 5, and that is equal to 0. Gosh, I'm gonna have to do it over here. Okay, let's see if I can make myself understood. I didn't mean to confuse you, but hey, stuff happens, right? So this is what I had. I had x squared minus 5x. That's what I had, equaling to 0. I took out the common factor, which is x, okay? And then I wrote whatever I had left. X times x is x squared, and x times negative 5 is negative 5x. This is still equal to 0. So now I equal each of the factors that contains variables to 0. So x equals 0. And also, what number minus 5 is 0? X equals positive 5. So these are my solutions. Sorry for all the mess that I created right here, but this is the right way of doing it. Okay, so let us move on to the next problem. Solve this? Sure. And now you understand why I don't like to use pen. Especially me, I make a lot of mistakes. Alright, so here, I see that it's 3 terms. I see that I can actually factor regularly. So I'm gonna try to find a GCF. There is no GCF. Okay? So then I proceed to open the parentheses. Factors of x squared, x and x. Factors of 10, there's only 2 factors, which is 5 and 3. How do I get negative 3? Oh, sorry, 5 and 2. Sorry, 5 times 2 is 10. How do I get negative 3? Make the 5 negative, make the 2 positive, and when you multiply it, you get negative 10, so that's fine. Now remember, it's a quadratic equation, so it has to be equal to 0. So what number minus 5 is 0? 5. What number plus 2 is 0? You already know the relationship, that is the opposite. So that's what you get. Alright, so here once again it says solve for y by completing this square. Sure, I'm gonna complete this square, I don't have a problem with that. First, let me set everything equal to 0. So I am going to subtract 9y on both sides, so I'm gonna get 2y squared plus 4 minus 9y. Okay? And now it's equal to 0. Now I'm gonna start following the rules. It says move the loose number to the other side. Sure. So I get 2y squared minus 9y equaling to negative 4. Now it says take the linear term, take half of it, okay? So half of it in this case to me is like 9 over 2. I'm not gonna say 4.5 because I'm gonna get confused. Because then you gotta take half and then you gotta square it. So you end up with 81 over 4. Okay? So then and it says add it to each of the sides. Okay, no problem. When you square something, it always becomes positive. Okay. We got that, right? And now, after you've done that, made a mistake. Oh no, made a mistake. Look, after I get rid of the loose number, I'm supposed to divide by the leading coefficient. Oh my God, I'm supposed to divide by 2, divide by 2, divide by 2. This is not here. Now let's see what happens when I divide by 2. I get y squared. I get minus 9 over 2y equaling to negative 2, because negative 4 divided by 2 is 2. Okay. Now I need to take half of this. Now I know. So take half of this. Half of 9 over 2 is 9 over 4. And then when you square this, you get 81 over 16. Now you have to add it to both sides. Okay, that, my friends, creates your perfect square trinomial. So this becomes y. Now watch this. You need the sum of two negative numbers in order to get a positive. So what is the number that we squared? We squared 9 over 4. That is the number that we end up squaring up here to get 81 over 16. So it was 9 over 4. So that's how you write it. Your perfect square trinomial. And then of course equaling, now negative 2 over 16, I mean negative 2 plus 81 over 16. You know what, I don't have time to be thinking about it, so what I'm gonna do is I am going to just do this. Negative 2, okay, is it minus or plus? Plus, okay, negative 2 plus, and then I'm gonna go with a fraction, okay, 81 over 16, and that is 49 over 16. Thank you very much. So 49 over 16. See that? So 49 over 16. And now, guess what? I am going to square root the whole thing to get rid of this square. So I'm going to square root the whole thing. And then I'm going to end up with the following. I'm going to end up with y minus 9 over 4, okay, equaling, the square root of 49 over 16 is nothing more than 7 over 4. I know you are keeping up with this. I know this is difficult, but you are. And now, oh, by the way, this is plus or minus, okay? When you take the square root of something, it ends up being it ends up being plus or minus. So now we gotta solve for y, so we get rid of this negative 9 over 4, so we get y equals 9 over 4 positive plus or minus 7 over 4. Guess what? They have the same denominator. So all I gotta do now is rewrite it as y equals 9 plus or minus 7 over 4. So 9 plus 7 is 16. 16 over 4 is 4. 9 minus 7 is 2. 2 over 4 is 1/2. So y is also 1/2. Nice, right? Alright. Whoa. A contractor needs 54 square feet of brick to construct a rectangular walkway. The length of the walkway is, okay, first of all, rectangular walkway. So I cannot work like this. I need a visual. So I'm gonna create myself a visual. Rectangular walkway. This is the rectangle. And what do I know? That the length of the walkway is 15 feet more than the width. Okay, so this length is 15 feet more than the width. And now I know what the width is. The width is W, which I still don't know, but I just said I know, so I can give you a little confidence. Alright, we always write an expression or an equation in terms of the unknown. Alright, 15 more than the width, so I'm assuming it's W. Alright, so now watch this. Let me zoom in, let me see if I can zoom in. Oh, okay. Write an equation that could be used to determine the dimensions of the walkway. Well, what do I know? That the area of this walkway is 54 square feet, because it says it at the beginning of the problem, right here. Oh, okay. So I'm gonna write an equation in terms of the area. The area is 54 square feet, and it is obtained by multiplying the length times the width. Am I making sense? I know that this right now seems like, oh wow, an expression with letters. Still, it has to make sense. Alright, so write an equation that could be used to determine the dimensions of the walkway. Solve this equation to find the length and width in feet of the walkway. Okay, so I need to solve this, not a problem. First, let me remove the parentheses and use all the distributive property that there is to use. So 54 equals W squared plus 15W. This becomes a quadratic equation because it has the little square here. So I know that quadratic equations are set to 0. So let me make this 54 equal to a 0. So what do I write here? W squared plus 15W minus, right, minus 54. Because I gave it to you, and when you gave it back to me, it changed signs, and I put it on the other side. Okay, and now I am going to find the GCF, which I know there's none. And now I am going to figure out factors of W squared, W and W, because W times W is W squared. Factors of 54, 9 and 6. How do I know they work? Hello? They're not. Shoot. I made a mistake. They're not. You know why? 9 plus 6 is 15, but I need a negative 54. And if I add them up, they both have to be positive. Oh man! What about, let me see if it works. What about 18 and 3? Sure, 18 and 3. Let's see. 18 times 3 is 54. I need a positive 15, make the 18 positive and make the 3 negative. So now 18 minus 3 is 15, and 18 times negative 3 is negative 54. Okay, good. So I set them equal to 0. Now you gotta tell me what the values of the W's are. Okay, it's easy from here. And now you need to choose which of the values is the one that I'm going to use, okay, to determine the length and the width. Just remember something. I have never heard anybody saying, oh look, this line measures negative 3 inches. So if the number is negative, I'm just letting you know, okay? Alright, so this is the end of this lesson. I'll see you on lesson number 13. Okay, bye-bye.